Hey guys, how's it going? Joe's back. You've probably been wondering what's been going on. Well, I've been going crazy with 3D printing, and basically I have two printers. I have a Delta and I have a Cartesian printer. The Delta I bought, and it's an Anycubic with linear rails. And I finally bit the big one here and got myself a real controller card for it. If you're familiar with 3D printing, most of them run Marlin, and they use an Atmega 2560 processor, which is like an 8-bit processor running at 16 megahertz. And it just really is maxed right out trying to drive these motors and get any kind of decent performance. So there are a couple of boards out there now that use the ARM processor. It's a 32-bit processor running at 120 megahertz, and it's screaming fast. And as a result, it can do a whole lot more than Marlin can do. Instead of Marlin, they run the RepRap firmware. So first thing I did was I upgraded my Delta printer with that control card. The Duet board that I have in here, it interpolates the 256 microsteps right off the bat, and it's running the motors times 16. So it immediately goes from something that sounds like a huge bunch of sirens going off to basically silent. I mean, you can kind of hear them, but they're really almost inaudible. And then what I did is I upgraded all my fans. I mean, that became the loudest thing, and so I upgraded all my fans to those Noctuas, and now the thing is like awesomely quiet. The Anycubic Delta came with these really lousy rod end type arms on it, and I got some Hayden mag ball arms, and I finally said, the ultimate thing would be to get the intelligent effector. So I splurged for that, and I threw it in there, and that has a strain gauge Z probe on it. And man, I'm telling you, once I put that thing on there, all the problems went away. I get perfect first layers every time. My Z heights are within microns. And so, I said, hey, now's the time to start screwing around with different materials and things like that. So I got some PETG, some TPU, and carbon fiber stuff, and amazing stuff. Once you calibrate it, and I'll show you the firmware here. Once you calibrate the printer, all the scales are within fractions of a millimeter, so you can do really accurate mechanical parts, which I have done for this Franken printer over on the other side of the room. I'm going to demo for you. But building stuff out of the carbon fiber filament with really accurate dimensions on it, you can make anything. And it's the carbon fiber is machinable. It's really strong. It's not stringy like the other filaments that you would see, like PLA or PETG. It basically becomes a solid block. And the pieces that I've been making for my Franken printer over there, I've been using 75% infill, and it's like aluminum. I mean, that's how strong the stuff is, and you can drill it, you can file it, you do all sorts of cool stuff to it. So anyways, I'll show you my Delta here, and I'll show you the web interface that runs that printer. It's amazing. I mean, it tells you the temperatures, the voltages, the velocities. It lets you step things. It estimates how long the job's going to take to print. It's really cool stuff. You can upload parameters to it while it's printing. You can change motor currents, you can change velocities, you can change extrusion ratios, everything right from the web interface. Now my printers, I have wired Ethernet all over the house, so I didn't bother with the Wi-Fi stuff. You can get two different flavors of that board. You can get a Wi-Fi or an Ethernet, and I got both my printers on fixed IP addresses. I keep the filament loaded up in them, and I can, basically download something from Thingiverse and send it to the printer, and it'll start doing it. And I'll just come down like a couple hours later, and there'll be a part sitting there. So let me show you, first of all, I'll show you my Delta printer and what I did to that to make it work. And then I'll give you a little demo of the web interface here. And then I'll show you what I'm working on next, because that's really cool stuff. Okay, so here's the Delta printer here. It's got a panel duet on it, which is a 7-inch touchscreen. I can control it right from there. But it's also got the web interface on it. And it's got the smart effector with a E3D V6 hot end, a 40-watt heater, and two Noctua fans, one for the heatsink and one for the print cooling fan. And this PC board here is a strain gauge. So when the nozzle touches the bed, that's like the Z probe. There's no offsets or anything to it. And from the web interface, I can home stuff. I can move it, do whatever I want here. Right now it's saying the Z is on the bed, and it literally is. You can do auto calibration. I'll do a little auto calibration for you here. Okay, so with those 4 points, it has now calibrated all the rod lengths, the bed tilt, everything. And then you can also have it do a mesh grid compensation. And what happens with this is I have this G-code in my slicer. So whenever I do a print, the first thing it does is go out and map this bed here, like this. And, like I said, it compensates on the fly for all the tilt, or if there's any kind of bowing in the bed or anything. So once this is done, no matter where you put this nozzle on the bed, and you tell it where to go, it goes there, and there's no offsets or anything. You can hear that the stepper motors are completely silent, the fans are completely silent. I think most of the noise is coming now from the belts. Okay, and here's the map. This is what it got when it calibrated. It's got a mean error of 0.136 millimeters and an RMS error of 0.036 millimeters. It doesn't get much flatter than that. That's really insanely accurate, and you'll get perfect layers when you do this all the time. I never have sticking problems. I print right on glass. I don't put anything on the bed. It's just a clean piece of glass that's heated up. Let me see here. If I home this, okay, and then say I set the heater. I'll show you how fast these heat up. This 200 degrees C I just put in there, and now I'm turning it on. So you can immediately see over here in this temperature graph, it's going up. And that's reading out what it is here. So 50C already, 60C, 75. I'm running my heaters off 12 volts. I don't bother with 24. It's fast enough with 12. It's already up to 120C. 140. So you get the idea. And it's all PID, temperature compensated. There's a thermocouple in the heater block, and now it's wicked accurate. I mean, you have to calibrate it. It goes through a calibration sequence when you first commission the printer. You know, because it has to get like the thermal inertia of the heater block and how much power the heater puts into it and this and that. There it is, it's already up to 201C. It's leveling off here, you can see, and it'll just stay there within, you know, a couple of tenths. I have my lights hooked up to a fan control because there's extra ones. So like, I can set the intensity to whatever I want. Turn them off. Put them all the way up. And the effector has lights on it as well that light up to illuminate the print. It's kind of a bad angle, but you know, there's, if I extrude some filament, you can see it coming out. That's carbon fiber right there. And it's strong, man. I mean, you can't break that. No way you can break that. So that's the scoop on that one. Shut off the heater, but you can see the profile of what it's doing here. It's going to start dropping now because I shut it off. Another recent addition is Billy, Shop Dog Billy, who is going to help us take care of business around here. She's a rescue, and we just got her a little while ago from the SPCA. She's a great dog. Billy, come here. Come here, sweet. Come on over. Come on. Yeah. Come on. She's a little camera shy. Come here, sweetie. Come on. Come on. Come here. Come here. She's a great dog. Yeah, that's a good girl. She's about 8 months old. Alright. This next printer I'm going to show you, we call Franken printer. And what this was initially a prototype that was given to me by Anycubic to evaluate. And, you know, we did some reviews on it and stuff, and, you know, it's been sitting around here, you know, again with the Tri-Gorilla controller board in it, but I have since modified the thing big time. And what I've done is I've made a whole new carriage for it, which also holds the smart effector and a direct extruder. This here is just to route the filament into the extruder. So this here is my fast printer, Doesn't have a huge build area, but I can control it from the same web interface over here. So this will home, you know, based on that smart effector as well. Here it's going to calibrate the Z. There we go. It's home. Now what's really cool about this one is I've got both these Z motors connected up to separate drivers. So what I can do is run a script that I wrote which will tram this whole carriage. So the script is running now. What it's going to do is it's going to home, and then it's going to go back and forth and calibrate the level of the Z. Okay, here it goes. And now it's going to make a correction on one of the motors to level the whole carriage. And it does it 3 times because it's an iterative process. And now we have, this is perfectly level with the bed. Now the other thing I can do here is I can do auto bed compensation. And what this is going to do is it's going to level, and now it's going to sample the bed at 25 locations and create a map of how level the bed is in relation to the head. And I got to tell you, this smart effector is the best thing since sliced bread for 3D printing, because there's no offset. It uses a strain gauge with the actual nozzle. I'll go into more detail on how that works with this particular printer, but it's amazing. I mean, I'm getting micron type accuracies with this thing. And what this will do is it will generate a CSV file of the bed at these, you know, multiple points that it's sampling here, and dynamically correct for any bed tilt or variation in the system. Now I'll show you. Here's the map that it generated. Okay, so basically it's telling me that the mean error is 0.038 millimeters across this whole thing, and you can see I've got a little bit of correction on one of the corners. I'm not exactly sure why that does that, but it doesn't really matter, because as the print is being made, it will automatically correct for this offset, and I always get perfect layers. Now, you know, I mean, 0.038 millimeters, that's hardly anything. This lowest point here is minus 0.2 of a millimeter, 0.191. Compared to like this highest point here is plus 0.135 millimeters positive. So, you know, these are very minute numbers that it's dealing with here. But as the head is traversing this, it will automatically follow this plane. And I get perfect layers every time. It's really quite an incredible thing. So anyways, that number, that map is stored now in the firmware of the computer automatically. There's this is the main screen here for machine control. You know, XY coordinates on the drives, voltage readings, microprocessor temperature readings, the Z probe. There are speeds. When this is printing, this will give you the requested speed and the actual speed. You can do extrusions to test the extruder and calibrate it. This screen here is the job status. Now what this will do is it will show you the actual heater temperatures. It'll show you the layer statistics for every layer that you print, times. It does estimations on when the print will be done. What's really cool is when this thing is on, you know, because it's on the network, I can see this screen or any of these control screens from anything in the house, my tablets, everything, which means I can monitor what's going on without even being here. Here's a G-code console for sending commands to it. G-code files. These are prints that I've printed up here, the name of them, how big they are, the heights, the layer heights, filament requirements. I recently switched from Cura 3.60 to the 4.0 beta, which has some pretty cool features in it. You can make your own macros. I've got like that tram macro here. There's a filament library, which I haven't really filled out yet. I just usually set the filament up in Cura and let it, you know, do everything for me. In the settings, you can upload new firmware to it. You know, you can choose what buttons and things like that you want this web thing to display for you. These are various options for setting heater temperatures and chamber temperatures and motor speeds and things like that. Now this is how you modify the particular behavior of the system. Like for example, like there's a config file here. And what this does is it has all the machine particulars in it, like the name of it, what the network IP address is. I use fixed IP addresses for all these printers. Which directions the motors go, how many steps per millimeter all the motors go, maximum speeds, maximum accelerations. There's stuff about the actual envelope of the printer, X, Y, and Z stops, the Z probe, things for the smart effector, heater calibration numbers, fan speeds, thermostatic values. Then I have like custom configuration stuff here too, which tells it to, you know, whenever I start up, it loads the mesh bed compensation, maps out the Z motors for the two, well, it maps them all out actually, but this one here pretty much tells it what drives to use that I have wired up for those Z motors, probe sensitivities, and custom configuration values. These are values for how to home it and things like that. It's really amazing how easy it is to do this stuff, you know, to modify it. Here's the height map that we just generated. These are macro files for homing, pausing, resuming. You can pause these prints. You can it'll save the actual location of what's going on. So like if you wanted to change filaments for some reason, you could pause the print, unload the extruder, put a new filament in there, and then resume it. It would start right over from where it was. And like I say, I have these control boards in both of these printers, so you know, it's seamless. I mean, it's a really powerful thing. The way this smart effector works is it uses a strain gauge that's mounted on this PC board, and when the probe contacts a surface like the bed, it flexes this PC board in a minute fashion. I've got this suspended about a ½ inch from my rigid support here, so it will allow it to flex and detect when it's in contact with something. This thing is designed for a Delta printer. You can tell by the triangular shape of it. But what I've done is, the problem with extruding TPU is that it's like pushing a string, and it really doesn't work well with a Bowden type extruder. You want to have direct extrusion. So what I've done here is I've made adapters for this thing, and the way it works is there's a piece of this PTFE tubing going down inside from the extruder through the gap here and into the hot end heatsink. And you can see that the extruder wheels here, let's see. Okay, so there's a metal sleeve here, and that PTFE tubing that goes down into the hot end goes right up into this metal sleeve. And it's really close to these wheels. So there's really no way for the flexible filament to not go down that pipe. I can maintain the pressure required to extrude it by doing this, and it's right there. I did try to extrude TPU with a Bowden on the other printer, but it's just too much of a lag. When you got to drive TPU through a big long piece of Teflon tube, you know, the extruder will pressurize it, will push it, and when you tell it to stop, it doesn't stop because there's so much elasticity in the filament. So, you know, you can't use retraction, you get a lot of stringing. It's a big problem. With this direct extrusion methodology, you can retract it because there's only like 3 inches between the hot end and the actual extruder wheel. So this works really good for being able to do stuff like that. Of course, with this I can run PLA or anything else, but this particular printer, because of the fact that I've mounted this extruder on this carriage, allows me precise control over what goes down through the hot end. And it works out really well. I mean, I do have some prints here of like fan shrouds and stuff that I've made. Let's see if I can dig one out to show you. You know, here's an example of a fan shroud that I printed, and it's with TPU. It's super flexible, and it works great. I mean, this, you know, you can't hardly even see the layers in this. Let me get you moved here so you can see what I'm talking about. So, like, you know, this would go around the heat sink, and a fan would mount on here, so you can, you know. But that's the flexible stuff, and I mean, this thing is strong, man. You cannot take this apart. It's solid. It's like a solid piece of plastic. I mean, it's unbelievable. So that's what I print on stuff like this. Now, on the other printer, that's my high precision printer, and what I can do here is print carbon fiber. These two Z supports, this one and this one, were printed in carbon fiber on the other printer. And I mean, it's amazing the strength of this stuff. I'm going to try to zoom in here and show you how good these prints really can be. I mean, look at the detail in this stuff. It's just beautiful, beautiful material, and it's very strong. I mean, you know, you're talking like almost like real carbon fiber. So, you know, basically modifying these printers for the duet boards is not really all that hard. You know, the other one is kind of buried in the guts, but I can show you this one. You can see the duet board right there. And, you know, it runs off the land. These are, let me see if I can point to it. These are the 5-stepper motor drivers right there. And you don't even really need heat sinks on them because they're so efficient. They'll drive these motors at 2.5 amps. Now, I've got them set to like 1 amp and they're fine. This one here, I'm running 5 motors on it. X has 1 motor, Y has 1 motor, Z has 2 motors, and there's an extruder motor. And it was nothing to get it to do that. You know, you can assign whatever driver you want to whatever axis you want. This board, you know, is primarily made for CNC type stuff. So it works great. So that's Frankenprinter, and you know, I just finished it. It prints good stuff, not really suitable for flexible filaments. Well, she just discovered James Gandolfini. Oh man, isn't she cute? And when she grows up, she's going to be a good shop dog, right? Yeah, she's a good girl. Just got out of jail. Got her from the New Hampshire SPCA, and I think we got a real good one. I mean, these dogs, when you get them out of the rescue, they have it's like dog jail, you know, and they really appreciate it when you get them out of there and give them a home. You know, when we first saw her, she was petrified. You know, basically they have like just rooms full of cages, and you know, there's millions of other dogs in there. They're all, you know, barking. It's like dog jail. And you know, when we first saw her, I mean, she was so timid and petrified. And you know, we picked her out, and they let you walk around. They have like a big area in the back where you can walk them around. And she was, for the first 15 minutes, she was terrified. She didn't want to do anything. She didn't want to go anywhere. It was real hard to get her to walk. And then once she realized like we weren't going to hurt her, she just started acting like a normal dog again. We walked her around for probably, you know, 45 minutes or something like that. And then as soon as we started heading back to the building, she started acting weird again. She hated it. And you know, she's leash trained, she's house trained. We don't know the history of her other than she came from Arkansas. She was, you know, one of a litter of 3 dogs, and they brought her up here, and we think she might have actually been in a foster home for a while, because she is housebroken and she knows some tricks. She knows her name. I mean, we named her Billy. They were calling her Sadie at the shelter, but we started calling her Billy, and now she responds to that Billy, Billy, come over here, sweetie. Say hi to people. What a ham. Yeah. So anyway, that's the new addition to the house here, Shop Dog Billy. And you'll probably be seeing her in some videos every once in a while when she's out there with me. Okay, printer's all warmed up. We're about to start printing a fan duct here. There you go. New fan shroud. So we'll let this bed cool down because I know that this thing is stuck down incredibly well. And I don't want to deform it. But when the bed cools off, it'll just come right off without even, I mean, it'll just be sitting on top of there.